discuss a little bit with you guys. I hope you can see it well. So, why we use tokens actually? Does anyone has a good answer? Like, why don't, like, speaking purely for utility perspective, when we're saying ECC, this is not a securities, this is utility token, why are we not using ETH for that? Anyone?
Because we can't automate native currencies.
They're programmable.
They are programmable.
Native currencies are programmable.
Native currencies are not programmable.
Not programmable.
Yes.
The tokens
Because we can have some features.
Oh, okay, yeah, okay. So not programmable, adding more features. Okay.
You can manage like supply. That's
Yeah, you can manage some properties,
right.
which are different from, like, you cannot manage them on ETH, right?
Yeah.
Yeah. So, like,
to create a community.
oh, this is a good one. Yeah. So, like, it's kind of like green word there, so it's easy to figure it out. But, like, even if you go like step deeper, like, why Ethereum uses ETH? Couldn't they just design a whole blockchain system with a Stripe integration and relying on like stablecoin USDC and rewarding like USDC for mining operations?
Gnosis is doing that.
Really?
Gnosis, yeah, native currency is a stablecoin.
DAI, yeah, it is. So yeah, like, and it actually works well. You can define and you can do like, even like you could do like proof of work actually and reward, US dollars, which kind of makes sense to the extent that, you haven't, your electricity bill is in fiat currency anyway, right? So why, like, it seems like a reasonable idea. Still, like, most of the blockchains have their native currency. This is like actually like in my understanding, like one of the explanations for this is actually that if you would, like, let's say peg or like tie it to the native currency, that would create some perhaps even like economic disbalance, because interestingly, less developed countries usually have cheaper electricity, right? So you could design a system which actually like gives them more advantage for charging less for transactions processed through them. Maybe makes sense, but eventually the ecosystem is a great answer. Because it kind of creates, well, it's my interpretation, right? It's more of discussions. If you have something to object, I'm happy to talk, but from my understanding, it creates this gating to your ecosystem. It enables you to define the macroeconomic strategy and decouple from, anyone you don't want to let in. You can allocate the tokens, you can give it to your friends, you can give it to your strategic partners or whatever. And then this big evergreen thing, if you don't want to let it in, it will get stuck in these gates. It's going to be harder to get into that ecosystem for anyone who you don't want to let in. So that's a little bit memes from Lord of the Rings, basically. And I think that it's also like something that creates this like unique feature and like vibe of like feeling this infinite garden philosophy of Ethereum, which if you didn't check this website, I really recommend. I loved it, the interface and how they represent. By the way, should I drop the slides link to the channel? All right, let me do that quickly. All right. Yeah, it's amazing, like, philosophy behind the whole infinite garden, but it kind of like.
We don't have access to the slides.
Oh, sorry. Sure. All right. Should work now. the whole idea, basically, in my understanding, is that when you're entering some ecosystem through the tokenization or whatever, you're kind of like creating different reference point. Like it's like point from which you're calculating the values, and this on its own, it kind of like implies that you don't necessarily need to exit. It's like, you know, this meme about, I think I forgot to put it, or did I put it? No, I forgot to put it. It's like this meme like, are you saying me the Bitcoin gonna make me rich and earn me a lot of millions of dollars? No, I'm saying you don't have to, you know, get back to that system after you're exiting that, entering the crypto. So it's good. It gives a vibe, right? And it gives a lot of values and ability to define things. But then you cannot really sit there just alone on yourself. It would be super boring. It's all about networking. So networking is connectivity. So yes, you have this gating principle, but you want to let others into your economy. You want to integrate with other projects. Eventually, on say Solidity level, it means you want to do the external contract calls, and you want to, you know, do something with others. Perhaps you want to, you know, launch your own ledger and blockchain, but still you'll have a cross-chain bridges to do that, and it all brings us to this like problem that, you know, there are attack vectors basically when you're doing cross-contract calls, and I will touch briefly also the whole like peer-to-peer blockchain architecture at the end of the workshop. But I would separate, there are like 3 major types how the things can go wrong. And it's either like contract has a bug, it's like the simplest problem you can face, or it can be that there's just like some kind of pattern where you connect the system that like the graph becomes that you can reach some invariant state unexpectedly. And so that's the first example. Let's say contract B, like the arrows here, they show that contracts, that this contract is using C, A, and D. So he depends on a bunch of contracts, but no one really uses him. So like it's fine. He has a bug, it's his problem. No one cares really, right? But then let's say that you have some like F contract which is being used by others. It immediately creates this like propagating problem and vulnerability in the system. And then the worst case scenario, you have like D-Lake, which like everyone depends on him. It's like, is there a vulnerability there? It's immediately everyone is affected. And this is why like, I think this is important, because even we are trying to build this nice infinite garden, connected technology, gate everyone who we want to let everyone in, and there still can be some, you know, holes in the system, and things can go wrong badly. And so we're about to learn something about how to actually think about this on Solidity level. There are basically 4 call types to external contracts, or rather, shall I say 4 types how contract calls can relate to each other. And first, the most trivial one would be the, I hope it can be seen on the code, but I'm sure you already tried this in Solidity. So this is during the static calls. So if you have a method which defines that method is pure or view, or if you would define dot static call for external contract, you'd be reading some state. It's super simple, but this is like base of our connectivity between the contracts, reading them. So we have some assumption how another contract would work, and we're checking what's the state on what's the return values. Next is doing call, which is not a static anymore. This includes sending native tokens, ETH. I don't know if you have, oh, thank you. Let's really helpful. I don't know if you already tried this in bootcamp, but whenever you're actually sending ETH from a contract to another contract, there will be a receive function, which is something similar like a fallback function, which means that you're doing the call on Solidity level. It's not much different from just calling some function you defined in smart contract. And this lets another contract to do something, which is something you want to write the state on another contract, but it will spend your gas, and you not always necessarily know how it's going to happen. And you have to kind of like always think about when you're doing logistic call that things can go wrong. I'm just not sure how, but unless you know exact every byte of that contract call to the one you're calling. And then there are delegate calls. It's like library. You load another contract in your execution environment, and your contract basically delegates the logic with a full access to own storage. So in this example, like it's super like pseudocode thing, but basically, we have a Bob here recorded in our like zeros memory slot, whatever. We're doing the delegate call to the contract, which will store the Alice to this slot 0. So when we do this call, the state on the next transaction, once this is processed, or even through the transaction, the state will change, and the memory in this contract will become Alice, the record. Even though we're kind of delegating another contract, it records to the storage of it operates on the storage of the one who made the delegate call.
So it's like you're giving permission for another contract to change your own state.
It's like you're like calling someone, just real life example, you're calling someone and asking, could you please come to my home and like clean the dust from the shelves or something? You're kind of delegating this inside your storage. Whether the simple call would be like call someone and say like, dude, clean your shelf, which is do not come to my home and don't do it at my home. Hope that example answers kind of like things. And then there is like fourth, which I would like to touch, is caching. And caching is sometimes is not always obvious. But we do this often when we're doing this, like if you work with like libraries and stuff, you'll see, say, before executing some records to my own memory, I'm calling another contract and I'm asking him like some information. Very common scenario is to check if the contract is contract actually. It's like is contract function. It checks if another address account has any bytecode associated. Now we don't delve deep into that because actually it's not considered to be a secure way to check if the contract is a contract. That's a disclaimer, big disclaimer here.
So
yeah.
if like they pass the IP that EOAs can become contracts and actually have bytecode, that's going to break a lot of contracts in the ecosystem, right?
Yeah. It's because right now there is a lot of contracts which just verify that and it will break the assumption that it is not a contract, which you can work around it today as well, because today if you call another contract from a constructor, it will call back to that contract, checking if it has any bytecode associated. It will not find any because it's still in constructor. It hasn't been recorded yet.
So like assuming we are having this problem in the future, like isn't a good idea to have an API code to check if something is actually an account or a contract?
The problem with the CIP is that there is already legacy contracts which do something in some designated way, and you're likely unable to just modify their states. So that would be like, you'd have to basically do the bytecode migration for the whole Ethereum ecosystem. I'm not sure if they can do that, but there is discussion on that, and we'll see.
Versioning maybe, because there's no bytecode does not like catch the version of the Solidity that was using the contract. Maybe something like that as well.
Not sure, really. Frankly, I don't like the TIP too much. I think it will, like, if they pass it, I think it will, like, I think it's risky. Like, I'm not the smartest guy there in the room sitting on Ethereum Magicians Forum, but if I can go and find something that I consider to be vulnerable within like 1 hour of digging in, it means that there are some very, much more smarter, like North Korean hackers who are already like, they sit like ready, transactions ready, but eventually what will happen, it's going to the development network, test network, and you're able to validate. If you're able to create a proof of concepts that things do go wrong, then obviously that's going to be a big stopper there. But even without that, here is example from my code, and this is example of me caching some assumption about the contract. So here the ERC 165, it is an interface check standard to check whether the contract supports some kind of API. And I'm calling this contract here, so I'm calling the address repository. I'm checking its interface ID. And if it doesn't succeed on this check, I'll revert. And then here I'm doing new distribution record, and I'm recording this repository address. So that's my assumption. My assumption that this is not going to change in the future. And if you have, like here, for example, well, if the interface breaks, it's not a big deal, but sometimes you're caching some other information, which might be more of a problem.
Do you really think that support interface is not something that should be used as security checker? Like, actually,
it is not a security checker.
It's not. What is the actual use case?
The use case more like to make sure, like it's like assertion that your infrastructure will work once deployed. So you're
can you do that on the front end, on the off-chain side, like validate if the contract is alright, like using static calls and simulating?
Yeah, obviously, like the contracts are verified mostly, and you can check their code and see that it's going to work. Here, this is more protection. So this function is intended to be called by an owner of contract when he wants to add another piece of functionality, and he is a user, and we always have to assume that the user might just do the stupid mistake, like misclicked one, like he made like typo when typed an address.
But if you think, I still think that's a waste of gas, because like I could simply like for instance, my uncle one time he tried to interact with a contract. He took money and sent to the contract directly instead of like calling the contract, because he thought that there's no checkers that's going to avoid human stupidity. Like they're going to happen.
Well, I would argue there is plenty to counter like your mistakes and break, like if you're submitting some wrong data. This is why we're doing validation on that. Like we're checking that our assertions are correct. This is what we're doing here. We assert that users sends a valid repository, which to our extent, we are capable of checking that it at least declares its capabilities. It will protect from some of the mistakes. It is not strictly necessary. And it's not a security check, because I could return from that function anything I want. If it's a malicious contract, I can tell you I'm supporting ERC20 interface, and can be malicious contract actually not doing that at all. So this is more of, this is example here more like for, just to show like the whole assumption, because let's say this repository address is actually upgradable proxy. Someone upgrades it and like suddenly just decides to remove this repository interface from there, then our assertion is wrong. And if you do the same assumptions, let's say, sometimes you're doing these assumptions like, why I mentioned the contract is contract check, because sometimes you would check like, if this contract already has a deployed bytecode, then I have to be aware that he's able to do like all of the reentrancy stuff. It can like do the fallbacks and receive functions. Whether if I'm sure that, like I cannot be like, that's tricky. I cannot be like 100% sure it's EOA, but if I see that that's a contract, that's already like a flag. And people do cache it. Like when I was browsing for the issues and that the EIP and the GitHub, I saw plenty of such decisions. Yeah, so these four I would separate piece by piece. And in all of the cases, we basically, it rolls down to that we need to know what's like what the contract is going to do, how it behaves, and we have to assert for and assess any possible threat. Now, yeah, it's actually, yeah. So the delegate call is so we are moving like more like to like specifics of each type of the call, and this is what people are using in proxies. The whole concept of the proxy is quite simple. So you're putting some very small bytecode on new address. And this bytecode just declares that whenever I'm getting someone to call me, I'm going to delegate to another implementation. I'm not going to do the calculations myself. I'm going to call someone and ask him to come and do in my address whatever I need, whatever is requested to perform.
I didn't understand what is using external conflict as a library. Like, do you have an example?
Well, in early days of Solidity lang, they used to write that delegate call is basically using it as a library. So you have an external contract, and yeah, the upgradable, the Diamond proxy standard is a good example of that. It's ERC2335. Let's quick. Diamond proxies.
Diamond proxy.
The concept there is that in a Diamond proxy, you.
2532. Sorry.
Yeah.
2532.
Thanks.
Yes.
2532. So the whole concept there is that you have a branching function in your proxy. It's not just simple delegator to another contract directly, but it checks what kind of signature of the function you are trying to call, and it has a memory, it has a storage with a mapping for each of the signatures you whitelisted, which contract to delegate to. So if you're calling a function which is like, pick apples, then you're going to call like some apple picker contract. If you're going to call some another function, it might call like, pick grapes or pick, mushrooms, and it will delegate based on what the deployer specified. So this is basically creating like external contracts as a library. So you're choosing which one you're going to use.
Okay. So not all of them are delightful for that property, or all of them are.
Or contracts?
Yeah, all external conflicts have the property
why often we refer to the libraries, because if you're writing a library in Solidity, so you're writing like basically library and brackets, and you don't have ability there to write storage.
Yeah.
Right, you know that. So it will be. Let me quickly pull up and just let's do something. So. So let's code here. Let's say I write, see that? So that would be illegal code. You cannot do that. You cannot have a storage in the libraries. And that makes sense if you're using a delegate call, because the library is going to be deployed somewhere else.
And your storage is going to change.
And I need to change my storage.
Yeah.
So the library has no idea how that storage operates, my storage here operates. So it doesn't make any sense for the library to allow it to store the storage. So instead, what you're doing, you're actually creating like in a pointers, you'd call this, let me show you some library. Let's say here. So you're creating a pointer, like in hardware or embedded programming, or like in a low-level programming. Yeah, C would do. So you're saying that my pointer in a virtual memory, I have a lot of memory, right? Storage memory. So I'll just do the hash function, and I'll get some, integer number, which will be the pointer to the memory. And then I'll create a function which will get this position. Let's say this position. I want turn-based game storage position. And I will return the struct from, I'm returning the pointer to the first zero offset on that storage. And I'm saying that it complies to that particular structure I defined. And this is a library. So this is a library. And this is a legitimate way to operate on the memory here. So whenever you're going to delegate call to that library, it will go to this definition of how the pointers are defined, and it will drive your contract, and it will operate on the memory storage. And this is something you have also to consider, that if you're using a lot of libraries, that you don't have hash collisions. I have, this code is actually a little bit out of date. I think, I also don't remember the name, but there is a new ERC, which defines pattern how to define storage pointers. It was developed in OpenZeppelin specifically to ease out the audit process for this kind of upgradable proxies. Let's quickly check.
1967?
Yeah, 1967.
67?
Yeah, so it creates you a specification on, let's find here. It's also quite new for me, so I haven't really upgraded for this pattern yet. But I assume the idea here is that you have some predefined seed, and then you're doing subtraction operation here. I'll link it to the chat. Feel free to read it through, and maybe that's a good, yeah, so you're doing the assertions here, so you're doing the checks that nothing really goes wrong. And this is more for upgradable proxies. But the whole point of upgradable proxy is that once you change the implementation, you want to keep safe with your storages. All right. Are there any questions further here?
It's a dangerous field.
Huh?
Upgrade our content is a dangerous field.
Dangerous thing?
Yes.
Yes, like this is why like delegate call is like not recommended to use ever really. Like whenever you can avoid it, because if you call someone who is not trusted, it's like immediately you're losing the full control over your storage, and malicious contract can just destroy you in one transaction. But it doesn't end with here. So this is an example of a real hack that happened. You can check the blog article from where I took inspiration. It was AAV protocol, big DeFi protocol, and it didn't use any tricky like delegate calls. It was just reading state from another contract. And they were trusting this contract. It's not like it's a malicious contract they were calling. But the whole idea is that your vulnerable contract, it wants to call someone to check do some checks or do some executions. And it realizes that if things go wrong there, then I trust that this contract will revert the transaction, and then I will revert as well, and everything gonna be fine. However, you're passing some data, which adversary can. It's hard to sanitize data in Solidity, really. You are quite limited to your gas, so often you're just like, okay, you're just passing data, trusting that it's gonna be fine, that second contract is secure. But if you're like trying to manipulate the payload, you can try to seek, some ways how to trick that situation that that trusted contract doesn't really revert, but doesn't really do what you expected him to do. And this is what happened here. So they set max amount to swap the approval to the maximum value. And they expect that, if calling this transaction here, like we do the dot call, with the by call data, if it reverts, then the whole transaction together with this line as well will revert. What attacker figured out, that he can figure out such a by call data, which he can pass into that third-party contract in a such way that the swap will not be complete. And there will be leftovers here in the allocations, so the approval to spend. And since it didn't revert, the transaction ends, but there is approvals left which were unexpected. Because they were expecting that this call will fully utilize the approvals given here, but it didn't. And this is like basically, I'd call this like return status spoofing, but I don't know what's the best name here actually.
This was from League?
Yeah.
And they actually had a variable called Augustus?
Ask them. I was also like because I'm from Latvia, we have such a name popular in country. One of my friends is Augustus, so I was like, well, the dude is famous, I don't know. But yeah, it's like, I think it was not really like super big loss for Avi. I think it was like $56,000 equivalent. And if I'm not wrong, like this particular case, we'll get back to that later, but the monitoring systems allowed to be aware of that problem is happening.
And like the problem is not just like if losing the money, but a lot of protocols, lending protocols, they use the same code. So when one of these hacks happens, all the other protocols get hacked in like on the same day.
Yeah, it happened a lot like with the Compound actually, because there's a lot of forks on Compound, and there are a lot of like there are like rounding errors known problem in the Compound v2 I think, and then there are some known problems with like front running the initialization process on the new markets. So people when they fork it, like they don't know how much like they basically like Compound pays. I think it's public information. Like Compound pays like $4 million to Open Zeppelin yearly for security services. So how much security is being put there? Plus there is a gauntlet working who are like they're more on financial security side. So like there is a huge security console behind which keeps the Compound safe, and even for these guys, I'm sure that sometimes they just like wake up like and like, damn, we have like to do something right now because it's dangerous. So forking DeFi protocols is, well, if you want to do that, good luck. It's hard, it's challenging. I think it's one of the hardest. Actually, the DeFi space itself, like the DAOs, like some token, like NFTs, is much more simpler. But the DeFi, because the flash loans and because of the financial uncertainties on the oracles, it's crazy. But yeah, any questions here? Yeah, so like I can take like example of a DAO quorum attack on this. I didn't put the link. I'm sorry. It was just like, and the slide is not perfect. I was really running a bit short on time preparing that. But here's the thing. This is a hack which happened to Aragon DAO. So if you know, Aragon develops governance framework, and they used to have own DAO structure, which was legally incorporated in Switzerland as a foundation, and it was legally by the laws of Switzerland what's the English word, obliged to conform with the law of Switzerland for non-profit foundations. So the DAO operations has to comply. And then like they had like I don't know 200 mil or whatever like in the treasury, which was a non-profit treasury. And suddenly there are people who say, let's distribute just these tokens as a, like profit to us. So that was like basically attack on governance, and it was attack on the constitution of the whole structure they had. And they did everything they could. They did the social manipulations, the tricking people into voting for them, but they also, and it doesn't touch us just Aragon DAO case. It also touches like Compound, like for instance, when your voting tokens sit on a centralized exchange wallet, you don't really see who owns that, and therefore you cannot really understand how much quorum shares someone has, and you don't really see these trades happening. So this reliance on like just some wallet is already like a dangerous behavior. And then if centralized exchange wallet gets hacked, it's even crazier. But they kind of like have to live with that because this is how it rolls today. And then there are also decentralized exchange where people would put the liquidity, but at some point someone might just like there where like flash loans can come in. Someone can take a huge flash loan, buy as much governance tokens as you can, and if that, by the way, flash loans do I need to explain? Okay, cool.
Like within the same call, you also have like small.
It's like in the same transaction, you're going to the DeFi protocol, you're taking a huge loan. It's really limited just for the DeFi protocol ability to give you the loan. But the only condition is that you have to return funds back with a profit to the protocol in the same transaction. So it's super easy for a protocol to, you know, kind of like give it huge loan because it will, you know, it will give immediate returns and everybody is happy.
Also for trade washing.
Oh, it's crazy. Like I think it's like this is like one of the most evil things in DeFi protocols, being able to take the flash loans. Like the invention of this like made so much complications in many people's lives. Because yeah, you can make money, but most of the time you're taking flash loans, you're doing something like, well, the only thing I consider there is useful for the ecosystem is doing the arbitrages, because arbitrages are needed. Otherwise, you don't have the market really. And then like, yeah, so you maximize your governance, and if the DAO can like execute transactions quickly, you're basically getting the quorums, launch a vote, vote for it, you know, execute in favor of your wallet. And this is why today the DAO operations, they're kind of tricky, because like actually if you check like most of the famous DAOs, they have like a quorum threshold of like 4%. So it's like not 51% attack, it's 4% usually of total supply.
In this year in March, I think, or April, our company found a loophole in ENS that you could steal $48 million because like somebody was buying up the tokens and like the threshold to get all the money in the treasury was getting to like a sweet spot, and they calculated how many was on exchanges, how many was logged. And we realized that somebody could just do like borrow from a lot of exchanges and places, and simply like they will have to spend around like $60-70 million, but they would profit like $48 million. And like some people were silently doing that, then we ended up realizing. And like ironically, that happened to Compound in 2 months ago.
Yeah, it was crazy. Like. The thing is that like the guys who concentrated governance power in Compound, they were like, they didn't want to go badly on about that. So they kind of like, they got a big threshold and everybody was sitting there on Twitter or discussing that Compound is done. But then they canceled their proposal just based on the Security Council and community were shitting on them.
They made a deal.
I didn't know about that. So.
Yeah, they made a deal because they wanted, actually what they saw an opportunity to take over Compound, like I said, but like the guy that was doing that, he's famous for like doing that. He did that as well with Balancer back in the day. So, but he's not like an evil, that much of a
yeah, it's a white hat more. Yeah.
In a way that he wants to hurt, but he wants things his way, and he's using his money to buy that way that he wants. So he made a deal with Compound and requested that they implemented some features that's going to provide more liquidity for the tools that he wanted. So they ended up making this deal. They pulled back the offering, but now they have to make this proposition for the better liquidity.
Yeah, so it's like it's crazy, and it's all connected to, you know, this again getting back to the ecosystem, ability to put on centralized exchanges, decentralized exchanges. But like right now, like solutions there are like basically, yeah, like negotiating. And actually for any contract, so I didn't mention in the previous lesson, but the one platform, whenever you go into production, really super recommended is to use the Immunify platform, which is like a bug bounty platform where, oh, cool, yeah. I think like I didn't put in the slides, that's for sure. I was like reviewing yesterday, I was like, because it's great. Like people can just come and do like the white hat, you know, report the issues and get their 1 million rewards if you like. Like if you figure out the bug in, I think, Scroll, they will, like critical vulnerability on Scroll will pay you like $1 million. Like easy if you can find it. But for just on-chain activity today with DAOs, it's a problem. That's one of the reasons like I'm working on like my project on Pyramid Labs now, because like I think we just have to put this whole concept of people going to fight for the governance quorums as a part of design of the system, and just like put it like already in the system design level. So if it's already in the technical specs that we know that's going to happen and we're going to play around that, it kind of like makes sense. But right now, yeah, the decisions, like the solutions are doing the time locks. The time lock contracts are available like in OZ library. Basically, what does it mean? That if, let's say, governance take a decision, it's time locked for, let's say, 1 week or a few days, unless this, and until this happens, people have time to exit the protocol. The Riot Guild, they used to have, like, that's another governance protocol they have. I think Moloch DAO uses another, like a lot of.
Lido uses a system where you need.
No, Lido is different, yeah.
No, Lido is different, but they have a contract thing that if you have just a small percentage of people voting against something, doesn't happen. So, like, if you want something to be approved, you need the 5%. But you want to like reject something, you only need 0.5%.
Yeah,
so
it makes
like,
sense.
If not everybody agrees, shouldn't happen. So
On the other side, it's a risk of denial of service.
yes, it is.
And then there were like these ideas of rage quitting, basically that you can build such a governance system where if the proposal passes, you can just click the rage quit button and execute all of the transactions which have to be executed to quit the protocol before it takes, before the proposal goes in. So you can, instead of voting against, you can just say, if you're gonna pass it, I'm rage quitting, which is like a fun name actually for that. And yeah, so Lido kinda, I would say this is nonlinear voting formula. And then throttling the transactions is something that doesn't exist yet, really. But in theory, like I was exploring this ability is just to throttle like amount of the flow of the tokens that can happen between the wallets to ensure that there is some bottlenecks that do not allow you to quickly like accumulate these governance powers too quickly on one centralized entity. We had this slide in a previous session. I don't have a link here, but if you want to get a link, just go find the link for the previous slides and you'll have there the link for the vulnerability disclosure. That was a third web vulnerability which shows address spoofing. And this is basically when due to some reason, attacker gets elevated permissions, which he shouldn't have, or he authenticates as someone else. And this happens again because you have some wrong trust assumption in the system. You might need, like in this particular case, what happens? Yeah, so the vulnerability uses two contracts, which is like ERC 2771, which is like the first account abstraction ERC which was out there. And 2771, basically what it says is that we'll have some contract deployed on chain which is a trusted forwarder. The trusted forwarder, whenever you're going to call him, will add the message sender from the payload as the last 20 bytes of transaction data. This allows me as a user to approach someone, and ask, could you please submit a transaction on my behalf? Create the transaction, maybe use like ECDSA signature inside to prove that's me, and then handle this transaction to the paymaster. The paymaster then sends the transaction to the trusted forwarder contract, and he specifies the sender, the real sender, the me, as the last 20 bytes of that transaction. And then whenever contract receives a transaction from the trusted forwarder, here, so we're doing the check, if its sender is a trusted forwarder, we're kind of getting back this 20 bytes. We're saying, okay, like, yeah, so this is a meta transaction, the paymaster doesn't really matter. What we want to get is like less 20 bytes and get your real address from there. That's a real sender. And this is safe. It's because it requires, when you deploy your contracts, already hard code that trusted forwarder address, so you already know how the trusted forwarder behaves, and it's safe. People use it, it's widely used pattern. Another contract which was used in this particular example was a multi-call. And multi-call is basically ability, it's not a standard as far as I know, but it's just a trick how to make the UX better. So instead of requiring user to like submit like one transaction, wait for it to happen, then submit another, then submit a third, you create this multi-call function, you're batching all of the calls you want in one transaction and you're sending them to the contract, which later does like, notably the delegate call, the dangerous one. Here, this is just like Open Zeppelin library, so actually, like, do you have questions of how this works, like address dot, where address is a variable? Should I explain?
I think I already covered lessons.
Huh?
Solidity lessons.
Yeah, so we're like using address for address trick. And then there is a function delegate call, and it delegates to itself, but it delegates just like this multi-call one piece by piece.
It's still dangerous to use like that because you don't have a boolean that says the transaction was successful or not. So even though it gets rejected, it will pass.
I think the function delegate call in Open Zeppelin library will revert for that. It's already checked there.
Okay.
So it is safe on its own. And the contract, it was audited, it was third web, so like people looked at that.
Nowadays they have the multi-call tree. In multi-call tree, you can just pick which kind of call you want to make. Have you seen that?
Not sure.
Try that on the very generic contract for this sort of things.
Tree,
like the number 3.
3 or IE?
The number 3.
Multi-call 3. Oops. Theorem Classic?
Yeah, you can type the first one and get it from a chain.
This one?
Yeah. Get one of the deployments so we can see the, yeah.
No captchas this time? Okay.
So it has all possible combinations from calls, delegate calls, static calls.
How long has this been out?
4 years now. Years. They're already deploying over 100 EVM chains.
Yeah, you know what's the difference here? Like this multi-call here is different because does it do delegate? It doesn't do delegate call, right?
Yeah.
It's a view function. So there is like multi-calls to do the view, batch the view, and this is just like reducing the RPC call load. So it's hard to get any vulnerability in this code. This is why most likely I'm not familiar with that, because like I wasn't looking at my professional work in this kind of contracts. What we are more interested here is the fact that this function, it lives in a vulnerable contract. So they are literally embedding this as a dependency in their contract. So it's like their contract is multi-call. And this leads to that function executing inside their contract on their memory. And then what did the attacker do? Attacker does this. So he sends the trusted forwarder the multi-call. The multi-call makes a delegate call, but the message.sender still is a trusted forwarder contract. And the vulnerable contract, first time he sees, oh, so this is a paymaster, let's throw this away. You know, what does this user really wants to do? Okay, so, you know, he wants to do the multi-call. Okay, let's do the multi-call. And then he sees in the multi-call, first transaction is again calling to the same multi-call. And he is going again to the multi-call and he's checking like, who is the transaction sender? And he says, oh, message sender is a trusted forwarder contract. Let's throw away again 20 bytes more from the end and use them as an address of a sender. So the attacker wraps two times. The kind of paymaster attacker, he creates transaction where first he mentions whatever which address, and then in the next 20 bytes he's mentioning victim, and then he gets elevated permission. He just got into the system. He tricked the authentication logic. Yeah, so these are like some of such interesting case of like solidity and vulnerabilities there.
You ever found like a contract that had this vulnerability like and it was live?
I'm not a security researcher. It's like back in the days when I was doing hardware development, I don't really like to dig into other people's devices and fix them. I'm more like designing solutions and exploring, okay, these are the problems, you know, how can we design a system to work with security. But I never, like, I didn't do the audits myself. Like, we mostly worked designing the systems around that. But I did work closely to the auditors, and I could see how the kitchen looks there in terms of that, yes, they find the vulnerabilities, they find the problems, and man, like, there is so many things you have to not like take in account, but like even like immutable variables. Sometimes if you just set the wrong variable as immutable, like, and then like let's say you want to change that variable later on because it's a security concern, and you cannot, and then the protocol is not upgradable. There's a lot of things happen. But the reentrance is one of the most popular problems.
The first popular problem.
It's still in a trend, you know. and the thing is, like, it's not just like one reentrance. There are 3 types of reentrances you can get. You can get like contract call, function call itself one more time, or you can get another function called on the same contract. And both of these are like quite similar, but I'll show the examples. But the cross-contract reentrance is something like quite more complex from that. So this is a simple reentrancing. Do I need to elaborate, or everyone knows? I'll quickly run through. So basically, you know, the attacker, he creates attack contract, he puts in a fallback function, the withdraw function, and basically what happens is that whenever he's calling an attack, doing the deposit and then doing the withdrawal, he's getting back to the fallback function, he's hijacking the execution flow, and he's doing the withdrawal once more, but this thing is still sitting and waiting for the first transaction to end up, and it's just gas limited, and that's pretty much is there.
There was this, can I draw something pretty quick?
Yeah.
About contract architecture that I think is very like good to know is like how you design operations one by one. So like when you see that this pattern in good contracts, you see that in the beginning we always have like, let's call them if functions. So like when assuming this is like a function. So you always start by doing ifs and check everything. Then what you do next, after all the ifs are checked, you change your own state variables. Let's go on state variables of the contract. And after you go, I mean like to avoid like retrace effects, after that you change your own system. You change like amounts, balances, and anything that you want to change in the contract, destination to, from, anything like let's call this the real storage and not validations. And then assuming you have like external contracts and you're doing external calls, sometimes you might bring this if back here to check something else, and then you emit events. I don't know how to draw it. You emit events, and then you return something. So like this structure is what you see in every single contract that's like good output.
Yeah, sometimes it's limited though to your ability, because sometimes you need to get this return statement in order to update the state.
Yes,
And
there's edge cases, but like in the average, it works fine.
yeah. So like the cross-contract reentrance is something that will really like will not even fit of this slide to show you on the diagram, but the whole concept is there that you will have to kind of like exactly to the right structure, and unless you do the right structure, if someone hijacks your execution flow, they can call you back, and then the third-party asset will be your problem and vulnerability point. And this is usually, so you're like sharing the same state variable, and you update them basically in a wrong sequence. And updating them in the right sequence is actually the only way to work around that. There is no like reentrancy guard you can put. You could, I'll get later like some holistic methods you can work around that, but generally there are none right now. So this is also this is a cross-contract reentrancy hack, which also you can scan and find the elaborated blog post about that. So we have like a token, and the token implementation is something that I would call strange from the very beginning also, because it has a function which is called burn account, which just specifies the sender. And it doesn't specify the amount you want to burn. And so what you're getting is basically the attacker creates a contract which will call, there we go, here by the arrows. Yeah, so it will do the deposit. From that, it will do the withdrawal function. The withdrawal function, you see that basically the state update is here and the call is here.
Should be the opposite.
And it's not very like, you even don't update your own state here. So it's not. And then we have some operational challenges. So let's forget about the smart contracts we're doing, but if we're designing the traditional IT security, we actually want to have the intrusion detection and prevention layers in the system to make sure that even if our authentication, authorization things go wrong, we kind of have ability to detect and prevent problems from happening. And ideally, we want to make this system so robust that our logic should operate and interfaces should operate 24/7, regardless of whatever happens. And unfortunately, some of these items are mutually exclusive. You cannot really have, like if you have a prevention system, you're kind of like implying that you can create a denial of service, for instance, and then centralization also becomes a question. For the detection part, there are a lot of monitoring tools. Like I just listed a few of them. For the hack I shown for Avi, actually, this is why they got such a low losses there, because they got alerted by the Forta network. I guess it was Forta network, I'm not sure. But the Forta network has these alerts. Basically, they just scan holistically the network. And because if you can see, like a lot of these contracts, they need to have a contract deployed to have the function for the fallback. If you're just scanning the network, it's easy to notice the pattern. The cache, the funding from Tornado Cash wallet, like Tornado Cash funded wallet, deploys a contract which specifies your contract address in its bytecode or memory. And this is a flag, like, someone who is, likely a criminal deploys a new contract, which is like what the criminals do, like on blockchain, and then he targets my contracts. And you can scan just the whole network and keep scanning, and whenever you find this, you can just create an alert, and then if you have, team and you have a plan to do response to such an incident, and you can just stay alert. You can like watch for this address and see for transactions. Yeah, the Forta is kind of like, I guess, the only one who's trying to decentralize like monitoring services, but there are plenty of them. Like literally, it's one of the easiest businesses for Web2 companies for trying to enter the Web3 space. At least it seems. To enter is like to say, hey, we're offering the monitoring service. In reality, it's a little bit like, it's not that easy because like hacks still happen. But yeah, I invite you to have these links, and like whenever you're working on like deploying any contracts, have some monitoring to track along what's happening. And then intrusion prevention systems. So today, you can do the pause on the contracts. That's one of the common patterns, which is kind of it kind of sucks actually, to be honest, because whenever you're doing the pause on a protocol, you're basically causing a protocol to suffer losses. You're just stopping the whole system, and people don't like it because of being centralized as well. But it works. It saves funds. So it's just like whenever you have to do the pause, your security team has to assess, like, does it actually even make sense to do? Because sometimes the drainage or the vulnerability might be like, we know it's here. For instance, we know there is a big vulnerability. It's a 0-day, and we got it like disclosed in a responsible manner. So we know that at least we see that right now the attack is not taking the place, and we know that there is a 0-day vulnerability. Like, should we pause the whole protocol? It's a question, and every
single time somebody pauses their contract, everybody on the exchange starts shorting like
Yeah.
very heavily, because the exchange will not stop the trading, and all liquidity on the chain will stop.
Yeah. So it's very double-edged sword, and unfortunately, there is no better answer in the industry right now than basically combining pause and upgrade. So this is like, if your contract has both pause and upgrade, if you see attack happens or there is likelihood that it's going to happen soon, and you don't have time to fix the thing, just press the pause button quickly. And there have been like huge, actually, I regret I didn't put the slides yesterday when I was preparing. I found there was a case where a protocol saw they're being hacked. They lost around $3,000 on a hack. It's nothing. And then they paused the protocol. They wrote a quick patch to upgrade, and they forgot to initialize the value there. And after that, they got hacked for $3 million. Huh? Yeah. So it's like even if you do this, like do this carefully and responsibly. So yeah, actually when doing upgradable contracts, initializing upgradable contract is something you should be taking very seriously. If you leave some blank field, it's a problem.
This should actually be like fully scripted. Like they should like have a single button that like tries everything on the forked networks, and like 1 second later they can do it on mainnet with the same button.
Yeah, it's like
That was really something manual.
But from my experience, like even if larger protocols, actually DAOs have like a problem that like DAO cannot write code itself. It has to contract someone to write code. So there's a huge drag in the process of writing patches and fixes, because you just cannot really there is some formal process and there's like enterprise bullshit.
Well, we need an upgrade, so let's write a proposal for next week.
Yeah, basically you have a security console which kind of tackles with that, but the problem often is that yes, you have a security console, it can react quickly, but the whole this like one button testing infrastructure is not security console's responsibility, so it drags behind. So yes, you're a security console, you have to act, but the tooling is not there. And
I still think that we should use Pausable for things that don't carry liquidity. Because when you pause liquidity, you create like a huge liquidity gap in the market. And like that's why if you see like you have a staking mechanism for USDT, they're gonna use Pausable because it's a staking mechanism. But in the USDT itself, they're gonna have the freeze.
They have the freeze. They have
basically the pause for a single address.
Yeah, they can freeze singular address. There are problems with that where you can combine pause plus freeze, because like someone like especially on layer 2s where transactions are cheap, you can just like start distributing these funds like this, so they are not in a single wallet, and you'll have to like basically front run their transactions to freeze them, and it's going to be complicated. It's easier to pause the whole protocol, fix the state, or freeze accounts which must be frozen, and then unpause it. And you can do this in one transaction.
Still, I find funny how some people, they manage to get like $20 million from some protocol, $10 million, and they put in like in tokens that can be freezed, and sometimes those funds get freezed. Like if you see the USDT report, a lot of times people get this, the hackers get their funds freezed.
Honestly, I think that today the scene is really about that if you find a vulnerability, even if you do the hack, you just negotiate back with the protocol, and you're getting some 5% of what you stole, but you're left unharmed, because it's literally impossible. Like, yeah, you can use a Tornado cache, but
it's hard to take the money out.
But you won't be able to take out money from like laundered money. It will be blocked from any exchange.
Yes.
So that's a problem, and it's again like about getting back to this ecosystem. So you're kind of locked in this ecosystem after that, and there's so many ways around it. So it's just much more better to wear the white hat and go to Immunify. But sometimes projects have no Immunify program, and then this is what the white hat hacker will also do. They will write them a disclosure like saying like, hey guys, you have like vulnerability. The guys will not really react perhaps.
So, good question. Do you think if I found a vulnerability, I should do the hacking and then contact them, or I should just contact them?
I just say that people do that.
They hack and
they hack, and then
I think that's a better approach.
They hack and then negotiate, but I wouldn't give my opinion here on that. Yeah, like there are pros and cons of being a pirate, but yeah, like the industry actually goes forward. So the firewalls is something that like becomes a hot topic today. Forta network, which I mentioned before, they tried to do that. The use firewall was actually started by, I think now she left, that Mariko was one of the AI lead in Open Zeppelin. So they use AI to scan the transactions. I think their offer more is like on the whole consensus layer. embed like this firewall. There's another project like Fireblocks. Basically, the whole idea there is that you can have some side approval from decentralized network with threshold signing or whatever, saying this transaction is safe. And then you can either build this in a block sequencing layer, where you just throw away all of the transactions which are not treated by being safe, or you can have hooks on the contracts, and you can hook the contracts to security oracle which take information from such firewall, which is like less, it's not that good as having like basically on like block building level filtering, but it's less centralized. Because if you are like requiring some approval on like block building process, it's like very centralized action actually. Yeah, so like, but from my standpoint, like my personal research in that field led me to the developing for my application what I call the Ethereum distribution system, which basically allows me to create a factories of like for the applications and hook them immediately to some security oracle. And whenever like, and then security oracle can be chosen by the user, not by the protocol. So if I'm like, I'm trying there to like explore a little bit, changing the paradigm, actually how we think about the state, that the state itself not necessarily should be like if you are ERC20 contract, it just defines the interface. The standard defines the interface, it doesn't define how the state should be stored. In my opinion, when like the industry goes on and the users see the value, they will want to have state which always belongs to them, not to the protocol. And then think of this like more like operational system and giving access to your resources on your machine. So if you have like, it was a good example, recently we spoke, like let's say imagine you have an asset and you have a door, and the door is controlled by a Bluetooth module, and Bluetooth module is tied to your computer, and your computer obviously sees the Bluetooth module as just an address, same as in Ethereum, address on some PCI bus, and for the CPU is just an address. So operational system task is actually to isolate any application from direct access to this Bluetooth module, which kind of like controls the asset access. So this is an attempt there, but there is also ERC7746, which is very simple. It's just an interface. Whenever you're building an app and you want to treat some functionality as a middleware, which is wrapped by, let's say, security module, then you can do the 7746 standard. It's still being discussed, so also feel free to hop there into the discussion if interested.
That's your standard?
Yeah, like these are two things I'm developing. And like a lot of them came from the discussions with guys like from Aragon and from what I internally saw in Open Zeppelin happening, because I worked personally a lot with monitoring and operational side of things, and I could see that a lot of here's the problem, like these patterns, you don't want to implement them in a non-custodial protocol. You don't want upgradability. Like, because it creates the security issue itself. Someone has a keys to do that. And then if you're using like DAO to govern that upgrades, still, like the DAO can be hacked. So if you want to have more, decentralization, need some kind of solutions. And like with 7746, in theory, you could design a system where you can have decentralized security oracle. There could be like multiple companies managing that, and they could also like implement different solutions which like users could choose, protocols should choose, and actually like even monetize directly. Yeah, I'm super over time. I'm sorry for that. So I'll quickly just finish on the MEV and like blockchain infrastructure layer. So there is still this a problem that people will try to snap your transactions. They will try to do the oracle manipulations. They will do the sandwich attacks. And that's something you have to account for. But it's also a way to treat the vulnerabilities. If you have something is really sensitive, you could go to the flashbots and submit a private transaction to make sure that it really goes unseen as long as possible. Because private transaction basically it will wait until there is some ability to put it to the node which uses MEV boost to just pay that node to execute the transaction safely without putting it in a large mempool where everyone immediately will see what you're doing. And this is just like a small joke, like not a joke, but like a funny story recently. It's more like of conceptual thinking that is it legal to steal from the MEV? So MEV in nature is actually like most of the MEV is just making like getting the more profits from the user, and a lot of research shows that it has like centralization power. It's not helpful. A lot of times it's not helpful for a protocol, and it's kind of harmful. And then if you can figure out such a transaction which will actually make these MEVs think that they're making profit, but you're actually making them to suffer losses. Well, at least in US, the precedent shows that you shouldn't do that. Like the guys got jailed for that.
So isn't that considered an automatic transaction? So why it's illegal?
Why is this
Illegal in US?
So the legal thing here is that there are MEVs, they're searching for transactions, they're kind of like, I would say cheating on the users, because users are, but that's legal. That's a funny story. That part is legal. You can just like, extract maximal value from the users of Ethereum, that's fine. But if you're tricking the MEV searchers themselves to think they're making profit, and fetch a transaction such a way that they're maliciously crafted against those who are making life for people in the protocol hard, then actually they can consider this as illegal activity.
No, it's like Hollywood.
Well, I have a question. Does moving to China help?
I don't know. I don't know, frankly.
Why we have to obey US law on crypto?
I don't think we have to obey. I'm just mentioning that like if you have this question, then like at least in US like this is the case. If you have so many examples how this is being discussed in China, I would actually love to know.
I'm just saying the US legal has no law enforcement in China, so you are free to go with whatever the legal consequence from US.
Oh, yeah, well, good to know, right? I think one of the problems today in Ethereum space actually the most stake and the most nodes they operate from US.
Okay, so it's somehow like with Ethereum, well, de jure it doesn't need to obey US law, but in fact it has.
But like, I don't know. I personally don't understand the US lawmaker policy. Like, I think they already missed a lot of the market and they're missing a lot of the progress they could do. Like they have such a vibrant developer scene, but like all of the legal problems they have, it just causes so much damage to their economics by now that I don't know, like. But I guess that if you would like, it's just like people are like, their people experiment on that. I never heard like any news about like people trying to steal from MEVs in China, but I assume that would be like, they would perhaps have a different position, like more like, I don't know. Yeah, and then just specific peer-to-peer networking problems. So it's more on the telecommunication side, but today one of the big problems in Ethereum And generally in blockchain is that you can develop these technologies basically only on what is like OSI level 4 and higher. You cannot really go on like TCP/IP stack and change it for something else. So you have this all like node discovery protocol, which is actually centralized for Ethereum. You have like 3 or 4 bootstrap nodes, which you'll use. And you'll kind of try to seek peer connections from that. And if you fail to get peer connections, then I assume that mostly are actually working through the RPC endpoint, which is just like one node. But here we're talking more about like the nodes network itself themselves. There could be things like an Eclipse attack, where basically if your node sees only malicious nodes, they can trick you in saying that the state is different, potentially leading you to the double spending. This is why if you ever launch a node, or even actually if you do like the RPC, for instance, in Ethereum JS, you can specify array of, like you can specify multi RPC providers, and it will actually on the background do check on the multiple providers that they agree. Because when you're just using one RPC endpoint, it doesn't say you anything. You're just trusting that node that it's correct. It could well just trick you and simulate the results of the transaction and never really submit it to a chain, for instance.
It probably does.
Yeah.
Is it like you have to start with trusting people?
Yeah, but like the blockchain concept is like initially that it's trustless system, and I think it's also a beauty that you can build a trust in untrusted environment. This is something we never had before. But yeah, there are the risks on that. Also, if someday you meet like some like really complicated time constraint requirements on reactive components of your system, I just invite you to remember that like Wrath from Paradigm, Go Ethereum, they have built-in, basically you can compile Go Ethereum with built-in monitoring system, which will do it will just have like much less lag when you're doing some reactive action, because the moment it sees something in the mempool or submit it for the execution, it will immediately scan it through your code. And the same hooks are on a Wrath, and if you actually have a use case to do that, then the Wrath is the better option. It's Rust, and it's much more performant. I don't remember now particular, but yeah. So the get, they are doing the synchronous calls. So if you have very hard processing, computationally hard processing, you can have a problem with just being below the block speed. But the Wrath is asynchronous, so it's better. Yeah, and then just the tooling. You can use some services like for doing transaction simulator, but I invite whenever you're dealing with a hard, complicated infrastructure to have ability to have the stack trace visible to you. Because this is the way you debug, and this is the way you actually inspect the vulnerabilities. No one does it on Etherscan. The BlockSec, they have a Falcon Explorer. The interface I'm showing is here. Just try to zoom this in so you can see. So when you're inputting the transaction on the Falcon Explorer, you're getting like much better visualization. You're getting the stack trace as well, so you can see the interaction between the contracts. It's much more meaningful. I really recommend having this at least small capacity of like reading that, interacting. And then if you're developing an open source, if you need open source tooling, the Hardhat has a tracer plugin for that as well. And then I have a cast CLI. And since you already started Foundry, I think it's very useful. Yeah, that's it. Pretty much. Yeah, I've been talking too much. Thank you for everyone who got till the end. I was waiting for that.